All right, so this is a quick review slash tutorial video on osmosis and how to distinguish between hypertonic, hypotonic, and isotonic solutions. So this is from Unit 2 Cells, Concept 2 Cellular Transport, and we are specifically talking about passive transport, a specific type called osmosis. Now, osmosis is the diffusion of water across the cell membrane. That's all it is. It's just water diffusing across the cell membrane. All right, and remember that passive transport does not take any energy at all, and it is when something moves from an area of high concentration to an area of low concentration. And we call this, we say that they're moving down their concentration gradient. They're moving with their concentration gradient. So for this type of transport, we're talking about water specifically because we're talking about osmosis. And so a funny little thing happens. We pretend like this is a cell membrane. So water is always going to flow towards the solutes, and it'll do this weird thing where it'll make the water seem to be unequal on one side versus the next, but really it's just flowing towards that where there's a higher concentration of solutes because it wants to spread those molecules apart. It wants to have equal concentrations. It's all about how much solute there is versus solvent. And if there are differing levels of concentrations, even though they're the same, like raw amount of water is the same on both sides, it's really not the same because we're talking about concentrations. If there's more solute in this one and less solute in this one, then this one's going to be a higher percent water than this one is. This one's going to be more solute than water, and this one's going to be more water than solute. And they do not like that. They want to equalize, even if it means like the water is all the way up here and all the way down here. So never forget this. Water always follows the solutes. All right, so one trick that I'm going to teach you is how to use the prefixes hypo and hyper to determine whether we're looking at a hypotonic solution or a hypertonic solution. So the prefix hypo means too little, all right? And then the prefix hyper means too much. So if the word hyperactive, you're overactive, you're doing too much. So that's how you always remember the word hyper. Hyper too much, hypo too little. All right, and when I say this, we're always talking about it from the perspective of outside of the cell. We're always talking about it from the perspective of outside of the cell. So let's look at an example. So here we have a cell, and this is the inside of the cell. This is the outside of it. So this is like the interstitial fluid, or just the space that is between every single one of our cells. And it's mostly water out here. However, there are tiny little particles. There's nutrients like oxygen, carbon dioxide. There's salt. Different ions. There can be tons of different little things floating out in here, okay? But the little tiny things that will be floating out here, the little particles, we call them a very specific term, and we call them solutes. So that's what I'm talking about when I'm talking about water follows the solutes. So solutes are what are dissolved in a solvent. And since we learned in Unit 1 that water is the universal solvent, it's a pretty safe bet every time, and if on an exam I were to ask you, that water is always going to be the solvent, and that whatever else is accompanying it is going to be the solute. All right, so let's say we have a bunch of these solutes inside the cell, and we only have a few, so we have less solute outside the cell. So let's bring this back. We're talking about this from the perspective of outside of the cell. So outside of the cell, there are less solutes, or there's too little. There's a lower concentration of solute. So we would say that this solution is hypotonic. All right, since there's too little solute on the outside, it is a hypotonic solution. And since we also know that water always follows the solutes, which direction do you think the water is going to flow? Do you think it's going to flow in, or do you think it's going to flow out? I just did that Dora thing where like you pause and wait and hope you answered. I hope you did talk aloud to me because that would be great. So if you said flow into the cell, then you were absolutely correct. So water is going to flow inside towards those solutes. And the same exact thing is true on the other foot. So let's say we have a cell, and we have a cell in a solution, and outside of it is swimming with solute. So there is a much higher concentration of solute outside the cell than there is inside. And since we're always looking at this from the perspective of outside of the cell, we would say that this solution is hypertonic because there are too many solutes, or there is a higher concentration of solutes outside of the cell compared to the inside of the cell. Oh, and so, since we also know that water always follows the solutes, water is going to diffuse across that cell membrane passively without energy, and it's going to move from that area of high water concentration to low water concentration. All right, but it's going to follow those solutes, that higher concentration of solutes. And then the same exact thing is true if we look at this a little bit differently. So if instead of actually drawing the solutes, if instead I put some percentages here, first thing to do is to always cross out these percentages of water. So before we do that, so what this means is, so we have a cell here where 30% of it is vinegar and 70% of it is water. And then on the outside, this solution is made up of 75% water and 25% vinegar. Okay, so now that we know that, so what I like to do is I always like to just get the water like out of the way. I don't like thinking about it. I don't like looking at it. I don't like thinking about it even just for too long. All right, so it's all about the solutes. That's what's important. So I'm gonna look and I see, okay, so it's 30% vinegar inside and it's 25% vinegar outside. So if we recall, water always follows the solutes, or it always diffuses towards the area of a higher solute concentration. We know that the water is going to flow in towards that 30% vinegar because there's more solute inside than there is out. And so again, if we were to try and determine whether it was hypo or hypertonic, we know that 25% vinegar is less than 30, so there must be less solute on the outside, so we know that this solution is a hypotonic solution. And then the same thing is true on the other hand. So if we're talking about another cell in another solution, a cell where it's 10% sugar, 90% water, and then on the outside in that interstitial space, it is 50% sugar and 50% water. So again, first thing I'm going to do is, I hate looking at the water. Don't let that enter your brain. And you're going to focus on the solute concentration. So inside the cell, it is 10% sugar. Outside of the cell, it's 50% sugar. So water is always going to flow towards the higher concentration of solute, so that water is going to diffuse out of the cell and make that cell shrivel or shrink in size. All right, and so now again, is it hypo or hypertonic? We look at which area we look at the outside of the cell and we see, does it have a higher concentration or a lower concentration of solute? And in this case, it has a higher concentration of solute. So we would say that this solution is a hypertonic solution.